Now, before we get started, I'll have to inform you that we are recording this webinar and we are going to transcript it as well. The recording will be available online, and if you do not wish to be recorded, please turn off your video or mute yourself. We will share the recording or slides with you following the event, and the session will be recorded or uploaded to YouTube. So today we're joined by two speakers, and when they are presenting, please turn off your videos and mute yourself to avoid any distractions. However, if you're free to turn on both for our Q&A session of the event, and if you do have any questions during the Q&A period, please use the hand raising function at the bottom of the screen, and we will call upon you. Additionally, the chat will be open for questions and comments from our audience throughout the event, and I encourage our speakers participate in there as well. I will encourage you all to ask as many questions as you possibly can, not only because we have a great and experienced panel of speakers, but because this year's webinar are organized around the different elements of the assessment criteria. Each webinar will focus on a different area, so you will be assessed on that in the final submission of pitching sessions. So today's session will be on innovation and the following assessment criteria, specifically the questions highlighted here. It is about designing for usability, what usability is and what sets it apart from other design elements. And we will also give you a few examples of good practice usability and technologies here on the Internet of Things, also known as IoT. And here is the agenda for today. We only have about an hour for today's session, and we will be hearing from our two speakers, followed by the Q&A. So without further ado, let me introduce you to our speakers. First off, we have Stewart Craine. Actually not, we're gonna swap the presentation, who's going to present first. So Michael Maina is gonna be the first one to speak. And Michael Maina works at CLASP, supporting research under the Clean Energy Access portfolio. And he brings over 4 years experience with research in energy and environment, providing advisory services in both the public and private sector. Prior to joining CLASP, Michael worked at EED Advisory Limited, where he provided insights in energy resources and demand assessments, use of spatial methodologies in energy planning and management, and renewable energy policy planning, among others. He holds a bachelor in environmental planning and management from Kenyatta University. Michael enjoys hiking, volunteering in wildlife conservation initiatives, and watching nature and history documentaries. So second off, we have Stewart Craine. Stewart has been involved in rural electrification since 1998, when he was the project manager for the construction of several hydro mini-grids in Nepal. This experience of seeing how engineering could improve living conditions for a rural village developed into a desire to do more of the same, but at a bigger scale. That would make more impact than the traditional aid, charity, and volunteer-driven models could achieve. So in 2012, Stewart founded Village Infrastructure Angels with 2 co-founders and some angel investors to move beyond the cash scale model into 3 to 5 year leasing projects, and to develop a wider range of powerful uses of solar, such as the concept of solar-powered agro-processing mills to help farmers use daytime solar power for productive income-generating uses. Stewart is now the managing director of VIA, So yeah, we have an exciting session planned for you today. And now I'll stop talking. So without further ado, let me introduce you to Michael. Please take it away, Michael, whenever you're ready.
Right, thank you very much, Emil, and the Design Challenge team. So my name is Michael Maina, and I work with CLASP as a research associate. So CLASP is a co-secretariat of the Efficiency for Access Coalition. So most of my work is mostly involved in the layer program. I do support activities mostly in the research side, a bit on testing and quality assurance under the Verasol program, which is an evolution of the Lighting Global Quality Assurance Program that was led by the World Bank and the IFC. And yeah, I'm glad to meet you all. And I do not have a presentation or a slide deck ready, but I am tasked today with talking about IoT in general and in the off-grid space, especially because this is where I have experience in. I know my bio read 4 years, but now it's more than 6 to 7 years actually. And I have been involved in various research activities here at CLASP, especially on testing of off-grid appliances, testing for usability, for safety, and specifically in field testing. And at least this is where we see, you know, the overlap of IoT and even PayGo systems and all these things. So I will talk briefly for about 10 to 15 minutes, especially about IoT and where we have used this in the off-grid appliance space, how it's evolving, and I will also give my thoughts on where I think, or what are some of the things that I think can be adopted, especially in remote monitoring. And Stewart, I know he speaks for himself, but we have worked with Stewart, especially in this, when you are beginning this field testing activity. Stewart was really instrumental for us in helping us frame or kind of narrow down in what we are looking at. Obviously, IoT is very wide, and the applications are far and wide-ranging. But for us, we were very targeted, especially on solar water pumps, on fridges, and we expanded this to even include solar milking machines. But in general, I know you all understand Internet of Things, where this is a connectivity of different devices talking to each other over the internet or over a specific network module. Data we have, comprises of data loggers, analyzers, and even actionable. The analysis can be actionable alerts, or even a specific command to an appliance, or even to a product, telling it, hey, shut down because this has gone above, or can increase the speed of pumping or things like this. But in general, we have IoT in the off-grid space, mostly utilizing PayGo platforms. I think this has been one of the game-changing technologies in off-grid space, where the pay-as-you-go platform has been widely adopted, especially in sub-Saharan Africa. We have this adopted in fridges, in TVs, in solar water pumps, and mostly why IoT and why the need to understand what devices, how products are performing. And mostly for manufacturers, one of the main need for them to introduce sensors and IoT technology is to understand how their products are performing in the field. And why do you need to understand why products are performing in the field? Obviously, when you design something in the lab or even in the factory, before you send this product into the market, you need to understand how it's performing. How is it adapting to the use cases? How is it being used? And are the components suitable to run in this particular environment? And I'll give you examples as I talk about, just maybe briefly about solar water pumps and refrigerators a bit. But one of the main things that we have seen this implemented is especially in debugging. And I'll give you an example, why, like debugging, when you have products out in the field, some of these off-grid products are out there in the field in very remote areas, you just need a system that can tell you that your product is performing well, to either detect a problem, for instance, if for a solar water pump, if the pump is almost running into a dry run, what they call a dry run is when the pumping level, the water level goes below the pumping level, and the pump can sometimes overheat, can damage the components. So when you have a logger that can detect that the water level is down, or even maybe the temperature has gone above the recommended, then it can be able to shut down or even alert them and the end user that, hey, your product, your well level is below the pumping level and you need to stop pumping, or even the device can automatically shut down to make sure that it doesn't damage. The other reason why we have IoT adopted in the off-grid appliances space is for continuous improvements. Obviously, the more you learn about how your product is performing, how well it's suited for a specific environment, for specific customers. For instance, a fridge that is used for storing cold beverages versus one that is used for storing vegetables or even milk. Sometimes how an individual fridge or a specific fridge or refrigerator performs in these different use cases is different. And I will just give some examples later on as I continue. Also, IoT has been very, very instrumental in understanding consumer behavior. So most people, or rather most manufacturers, design their products to purely understand the technical side of things, like my fridge is consuming this much power, or my solar water pump is consuming this much power. But also we find data on consumer behavior very, very useful, especially in when you're designing a fridge or when you're designing a pump. Like how long do end users use their pumps or their appliances? How many times in a day? How many times in a week? Obviously, this will tell you a lot, especially for battery-enabled appliances such as a fridge or a solar water pump. That obviously we understand that batteries, especially lithium-ion batteries, the way they're designed, they can only handle for a specific period of time. The charging and the discharging can only be for specific. They can only run optimally for a specific duration. And understanding how a user is charging and discharging their own pump or their own fridge can tell you a lot of how to size your battery. And obviously, this goes a long way in continuous product improvement. And just to jump into solar water pumps, and why I'm focusing on solar water pumps and fridges is because we, under the Efficiency for Access Coalition, rather under the layer program, we focus on four appliances, and we have fridges, we have fans, and solar water pumps and refrigerators. And refrigerators and solar water pumps have been, we have data to show that these pumps and fridges have the potential to have the biggest impact. Majority of users in the sub-Saharan Africa space, especially for countries, most countries under the sub-Saharan Africa region depend mostly on agrarian economy. We have very many smallholder farmers, and mechanization is very, very low. We have, major post-harvest losses, mostly because we don't have, efficient or cold chain storages that can help in, reducing food wastage. And also for solar water pumps in, at least, mitigating the effects of climate change, where we really cannot depend on rain-fed agriculture anymore. So for solar water pumps, we have manufacturers in, around the globe. We have the Lorenz, Sun Culture, we have Future Pump, Simusolar, and the rest. And almost all of them are actually currently utilizing IoT technology in their in their pumps. And these loggers and sensors, mostly they are installed for pay-go, because majority of these pumps are sold on a pay-go platform that you pay for what you're using. Sometimes it's you pay for a certain amount, it's going to last you for this long, and sometimes it's based on tokens that you're only paying to pump for a specific period. And how does the manufacturer or the distributor know that this person has paid this much and it's only going to last them this much? So it's obviously it's the loggers talking to each other, sending information that this person has logged in and they're pumping and it's going to last them this much, this long. So obviously information on daily energy consumption, as I've said, it allows for curtailment in pay-go systems, understanding how much water is pumped. And this, obviously, we're still in the height of COP26, and obviously we understand that climate change it's a major threat to most economies in the world, whether developed or developing. And you as upcoming designers or upcoming engineers, I think one of the areas that I feel is still lacking, even as much as we have all this innovation, smart pump controllers, we still there is an opportunity to develop products or even IoT technology that can be able to understand or even indicate the water stresses that you're having in a specific region. For instance, if we have this number of pumps deployed in an area, say a village, and we have all these farmers pumping, understanding when we start analyzing data and we see that we have these many dry runs occurring in a day or during the dry periods, obviously this is information that can be used to advise the end users that during dry seasons that you need to reduce your pumping, or you need to pump to be more diligent or even judicious in how you use your water, because obviously the water levels are going down. And another area that I think IoT and remote sensors can be very, very useful is in detecting water turbidity. Majority of pumps do not have this ability to detect water turbidity, and actually quite just last year, the E4A, in collaboration with the Schatz Energy Research Center, we wrote a paper on a memo rather on pump performance and turbidity. And this is a major issue that most people pump water either from a river or from a pond, sometimes from a well that's very turbid, and this destroys the pumps very, very quickly. Obviously, if you're pumping a lot of turbid water, your pump can only last for so long. Another issue, but kind of minor, is on water salinity. Excessive water salinity destroys the pump components, but this is something that we are still not able to detect at the field level. Sometimes, if I'm a willing buyer, I just want to go to a distributor or a manufacturer and okay, I need a pump, but really they don't understand what are your water characteristics, how turbid is your water, how saline is your water, what is the water temperature. So you have this blanket product, but that really is sometimes not able to adapt to the different characteristics of the environment. Another area or gap that I feel is on the solar water pump. There is an opportunity there. Obviously in the developing world, we have smart and precision farming. But in sub-Saharan Africa, we really don't have this. It's really a farmer deciding, I'm going to pump for 6 hours today, maybe to fill up a tank or to flood my farm or to flood my plot. But as we move forward, precision farming is something that I see being adopted, especially in sub-Saharan Africa. Smart controllers that can be set to pump for a specific period of time or pump for a specific time in a day, when the sun is not too hot. If it's a direct drive pump, you don't have batteries, you can be able to pump only maybe during the morning or even in the evening, just before sunset and after sunrise. You can be able to program your controllers to be able to pump this depending on whatever you're growing or whatever your use case is. I don't know if anyone has a question, or I can briefly talk about fridges, and then also I will share a link. Actually, let me just share this in the chat already on what I mentioned that we did a while back under the E4A to understand, ideal remote monitoring solutions for off-grid appliances. And we have a very detailed paper that you can be able to read through. Emil, should I continue, or can I take questions?
Yeah, if you can just continue the presentation, then we'll save some time at the end of the session. So yeah, please move along.
All right, thank you. Okay, so just briefly talking about fridges. I know in the developing world, obviously, we have fridges that tell you you're out of bacon or you're out of apples, but for the off-grid space, especially, this is something that is yet to be adopted. We are still far from that, but that doesn't mean that IoT is not readily used in off-grid refrigerators. And obviously, for pay-go platforms, this is something that has been adopted and is very much being used across many countries. I think Kenya is one of the biggest markets for solar fridges and even solar water pumps, where we have this the presence of mobile money really allows for use of pay-as-you-go business models. But for fridges, we have worked with manufacturers a lot, especially even as we test products in the lab and even as we continue to test them in the field. There's a big need for understanding how fridges perform in the field. And a fridge is a very delicate appliance compared to a solar water pump. And why I say this is because it's very dependent on how it's being used, how it's designed, and even where it's being used. So for fridges, as a manufacturer or even as a developer, you want to have a fridge that can be able to adapt for specific environments, can work optimally in almost all environments. Sometimes this is not the case, but we have seen cases where fridges that are performing, we have fridges like, we test them in the lab and they're performing optimally, and these are the results that we have. But in real world environments, for instance, some fridges we saw being used in Senegal, they are not able to freeze, even with the recommended power modules or power systems, or the sizing is optimum, but we are not seeing them. They are not able to even freeze, and this is rated as a freezer. It's not able to freeze because of the environment. And obviously, this brings in the question of understanding how your product is performing in these different environments can help you in designing the product that can be able to to perform in different environments. And why I'm saying this is, for instance, the fridges that we see in Senegal. The ambient temperature there is obviously very high. And what the manufacturer recommended to the distributor that this should be the sizing, it's not really working. And we have obviously customers complaining, but this is because the compressor is probably working way too much, above the recommended, work rate. And it's not, even with the power that it's receiving, it's not able to freeze. And this brings in frustrations from the customers, and you have to now try to debug and understand why this is happening. And also another thing that we have noted, this is a separate case, especially in Rwanda, where we're working with a manufacturer. They have their fridges, they have a freezer design, specific, or it's designed specifically for dairy use. And the problem is not in it's being used for other uses, but the problem comes in for the consumers, where they keep loading in, warm milk or even hot milk in the fridge. They're overloading the fridge. The fridge is mostly left open. The number of times it's open is way too much, and the fridge obviously have, the performance is suboptimal. And this is where we have this, we are seeing this in, we install monitors. We have internal temperature sensors, relative humidity, ambient temperature sensors, and even the door state sensor, where we're able to monitor how a fridge is being used, how many times is it being opened in a day. And obviously this information can be correlated with how the fluctuations we are seeing in the internal temperature, how is the relative humidity, affecting the freezing capacity or the freezing capability of a fridge. And this is some of the information that we are giving to manufacturers, even distributors, to help them either advise their customers or even help them in designing a better, efficient fridges, compressors that can work in, in hotter areas, helping in power system sizing. Obviously, understanding how one environment is, you can be able to, if a distributor is from Senegal, is from somewhere in North Africa, in the Sahara Desert where it's very hot, you can be able to have a specific fridge that is tailored for these very hot regions, and at least this can improve customer satisfaction. I will stop there and take any questions or reactions from you.
Thank you so much, Michael. A very enlightening presentation. It was interesting to hear about your usage of IoT and sensors and what it can be used for in the off-grid sector. You really covered a lot of ground in a short amount of time. So thank you so much for that. As I mentioned, we're going to save the Q&A for later on in the session, but everyone participating, feel free to pop a question in the chat, and then we'll move on to Stewart. So next up we have Stewart from Village Infrastructure Angels, and Stewart, whenever you're ready, just take it away.
Good day, everybody. Hope you can hear me okay. Just doing a sound check.
Yeah, it works. We can hear you.
Good. No problems. Sorry for the terrible photo there. Thanks for this opportunity to do some talking about product development. I've been working on products for the so-called bottom of the pyramid for the last 20 odd years, and I've made every mistake possible. So happy to share some of those with you. Some successes. Next slide, please. Again, thank you. So I'll just give a bit of background about VR because it does influence how we design. So obviously we're focused on the poorest 1 to 2 billion people on the planet in emerging markets, mostly in off-grid energy areas, but also increasingly on-grid things like cooking that also still need to be addressed, that electricity hasn't met yet. A lot of finance in the world is focused on richer markets, and even those that are focused on the emerging markets, there's a lot of early stage small capital and then a lot of bigger capital later, but there's not much in the middle. So that's sort of called the missing middle. It's where angel investors and micro venture capitalists can step in and help grow things, but it's also extremely difficult and dangerous. It's really hard. And you're not likely to have an IPO event at the end of it and have found the newest Google. So you also need to work out how you're going to get your money back out of these areas. So we kind of focus more on projects rather than products in terms of building things and investing. But increasingly, we're finding that a lot of other people are getting the funding for those projects, which allows us to focus on the products that they need. that they don't have yet. So that's something to think about as well. Are you a B2C project kind of entity trying to deliver to the end consumer, or are you a B2B kind of customer, entity serving others who ultimately end up reaching the customer? So that's something we're pivoting around at the moment. Next slide, please. Other studies have found that maybe 50% of what we need for the Sustainable Development Goals is related to infrastructure. So we took a very deliberate choice in our description of the organisation to call it Village Infrastructure Angels, not Village Solar Angels, not Village Energy Angels. Infrastructure is a well-known market, but we just don't do very small infrastructure in very decentralized, very rural areas very well. Most of it's been big and centralized. Microfinance also hasn't really got out to these villages and doesn't understand infrastructure and hardware very well. So there's this massive market that if you can make a good product, you can sell into that market. Next slide, please. Infrastructure, we divide into energy, water, transport, buildings, communications, machinery, and waste. And as mentioned, very large industries that you can see modest costs per solutions, but a lot of people needing those solutions. So there's rooms for dozens of unicorn scale $1 billion companies in this space. Thanks, Sue. Next. As mentioned, microfinance has grown up very well, but it tends to focus on just 1 and 2 year loans. To make infrastructure really affordable, you really need a longer period of time. You know, a big infrastructure, they get 15, 20, 25 years to pay off airports and toll roads and things like that. So why would the rural poor not be offered the same sorts of terms? It's very difficult. There's a hell of a lot more money going into infrastructure, much more than the 180 million going into microfinance. So again, if we can get a tiny bit of this money pushed in the right direction, then a big industry can grow out of this. Thanks again. Next. One of those that has been off-grid solar lighting in the energy space, mostly replacing kerosene lights. Before I did VIA, I grew a company called Barefoot Power from 2005 to 2011, and compatriots at the time, Greenlight Planet, D-Light Design, have now grown into $50 to $100 million businesses. Whereas my company blew up when investors took over and killed it. So it's also, you know, difficult to hold on to your business even if you do grow an interesting, good product. But it's a growing space, which is great, and we're seeing hundreds of millions get into the sector, and soon it'll be $1 billion industry. So we're off to a good start, but there's still a lot of work to be done. And these are fairly small appliances too. Yeah, keep going. Next, thanks. What are we displacing? We're displacing manual labor. We're displacing kerosene lamps. We're displacing cooking, washing, grinding flour by hand, literally Stone Age technologies. We're in the 21st century. My view, nobody should have to do any of this. So the existing problems, you've got a lot of space here to work in. Light, food, no irrigation, spoilage is already mentioned today. I got some interesting stories about melting ice creams in by people who don't know how to use a solar fridge that need a lot of education, but that'll have to come at the end if we've got time. And then, you know, looking at income, no value adding to these crops happening, a lack of productivity, people having to process crops by hand, have to travel a long distance to reach a mill, don't have carpentry tools to do things quickly, etc., etc. So there's a lot of solutions there, and we see that you need software and finance to couple together with the hardware, and you need to think about those in conjunction with each other. including IoT, as previously mentioned. Next, please. So here's some examples from Vanuatu where we've worked. So you've got a large piece of metal with a nail that's been punched through it to create a large cheese grater, basically. And they're scraping a cassava root over this to make a traditional dish called lap lap. So for a big festival, they may process up to 200 kilograms of this and be grating like this for 8 hours all day before having the festival food at night. When we brought in a solar-powered cassava grater, the women just went berserk and were so happy it wasn't funny. And the festival dinner actually moved several hours earlier in the evening because of the time we helped to save, which was much appreciated. The women also immediately said, we can rent this out. We can rent this machine. People are going to want to use it. So we've now got 100 solar-powered cassava graters in Vanuatu. Next, please. As mentioned, you also need software to think about planning, the spatial planning of where would some of these productive uses go, where should mills go, where are the population centres. A lot of that planning has not yet been done, so this is something else that we also help with, and also looking at electrification solutions between solar home systems, mini grids and grid extension, and what makes rational sense using GIS and planning software. And an understanding of where all the households really are and what infrastructure they need. If you overlay that with crop data and other useful data, then you can start to say, okay, here they need a rice mill, here they need a corn mill, things like that. So the software to help with planning and describing the market to potential investors and customers is, I think, quite important as well. As solar came down through $1 per watt, we found that solar in the daytime could power anything. It could boil water, it could do whatever. 22 odd years ago, when I was doing microhydro in Nepal, the go-to technology for the daytime was a mill. We couldn't find any solar-powered mills. There was lots of solar water pumps, but no mills. And you can't eat a food without processing it first. So if you have rice, you can't eat it straight off the plant. So we're talking about a need versus a want. So also think about that when you're designing products. Is there something that literally people need? They either have to process it manually or take it to a diesel or electric mill, rather than something that somebody might just want, but they might not pay for that if times get tough, like in the pandemic, such as a television, for example. So need versus want is one thing to think about. We're also working on several other things as well, such as solar electric cooking, solar washing machines, and multifunctional dryers. I've also got a lot of experience from the Barefoot Power days in solar LED lights to replace kerosene lamps. Next. One thing to bear in mind is how much is your customer going to save? So for solar lights, we had a simple thing. $1 per week can get replaced, that's of kerosene lighting, can get replaced by a $20, $30, $40 solar lighting kit. And people will save $50 a year, maybe $250 in 5 years, $500 in 10 years. Other savings are there as well. But also, out of that net benefit of over $500, how much are you making? Now, when we did Barefoot Power, we were just selling these products for, say, $30, and they cost us $20 to buy from China. We're only making $5 or $10 per product, but creating a couple of $100 worth of benefit for the customer. So the economic return for the customer was very high, but our return for the product was actually very low. Pay as you go, when you rent this kind of product to somebody over a long time, you can actually change that share of economic versus financial return. You can also go too far and say, hey, I'm not ever going to give them ownership at all. I'm going to keep on taking that $1 per week for the next 10 or 20 years. And companies have tried to do this and failed badly when customers realized they could get the same product with a 2 or 3 year loan from somewhere else. So balancing the customer internal rate of return and the investor rate of return, I think, is the holy grail here. You don't want to be too far either side. You don't want the customer getting too much return and you're not getting enough to survive. And you can't have vice versa, where you're getting all of the benefit and the customer doesn't really get much. Next. So product design issues. Apologies for the formatting. I don't have Microsoft PowerPoint, so it's a little bit kooky there. But anyway, so cost is obviously a key issue. It's got to be not just cheaper than existing technology, so that it's affordable to people, but it's also got to be investable. And a lot of investors do not want to expose themselves to the bottom of the pyramid for more than, say, 3 years. Let's take some examples of battery technology. Lithium titanate battery are amazing. You know, they've got 10 to 20,000 cycle life, but, you know, they cost 2.5 times more than more traditional lithium technologies. And probably a person who is using this battery is going to die before the battery does. But lithium technologies are like LFP and NMC, they are the ones that are really in most of your laptops and mobile phones, because, you know, if you've got a product in there that actually does cost more upfront but lasts forever and ever, you know, where's the replacement value for the for the laptop companies and the mobile phone companies? They don't want stuff lasting 30, 40 years. So the technologies are out there to get cheaper energy to people, but also we don't have investors that are going to give 10-year, 15, 20-year loans to the poor, even though they'll do that for large on-grid infrastructure. So that, for that reason, LTO batteries, even though they're the cheapest lifetime energy technology, never get used. So financing, and what the financing that will work, is a part of the equation. And why aren't lead acid batteries used so much? They certainly are in certain areas. It's still a battle. It's not always lithium. And that is a cheaper upfront cost, no doubt about it. But if you're looking to have longer warranties and say 1 or 2 years, say 3 to 5 years, your lead acid battery is not going to survive. So yeah, finance and technology selection go hand in hand. Safety is a key thing as well. AC voltages can kill. We all use AC voltages in our house, but we've had qualified electricians to put that stuff in. You don't have qualified electricians necessarily out in these villages. So using extra low voltage DC might be better because it's not lethal. Solar is a natural DC technology and now the cheapest option for most places, but most appliances are in AC, so you might have to change the appliance market locally. Inverters can change DC to AC, but they add cost and can be a central point of failure. So you want these technologies to really be field ready. So one of the things I have to also check is we don't have anything that's too big. If it doesn't fit in the back of a 4-wheel drive or a small boat, it's not going to make it to the last mile if you need a container truck to deliver it or things like that. And I mean truly last mile, not just be, you know, easier, low-hanging fruit. I'll give some pictures to illustrate this in the next slides. So when you're first shipping your product to market, after you've made your prototype, got your minimum viable product ready, you're now ready to ship at small volumes to new customers. And that's probably going to go on a 1 meter by 1 meter pallet. So if your product is like 3 or 4 or 5 meters long, that's going to be a little bit more difficult. So just the physical constraints of shipment can often suggest try not to make things bigger than about 1 or 1.5 meters. Next. This is what the last mile looks like in Vanuatu. You've got 40 inhabited islands with only 250,000 people in the entire country. Things are coming in by fiberglass boat, or they're coming in by 4-wheel drive, and things are getting carried that last mile. I used to build micro hydro turbines into villages in Nepal, sometimes 2 or 3 days walk from a road, and you'd have 10 or 20 people carrying in a fairly heavy turbine. So small, light, modular systems is how you've got to be thinking along these lines. Next, thanks. We had some nice Japanese technology on the left that had a plastic vein in the middle of the rice mill. That didn't last too long after 1,000 kilograms of rice went through it. It was a product that was really there for test purposes. So once you put your technology out in the field, you're going to find out what's going to break pretty quickly. Longevity testing is very important and often not done. Because donor programs are so short, and you need that 1 or 2 year of accelerated lifetime testing to be done. So the locals made up some local bamboo versions instead, which are a lot thicker and stronger than the plastic it replaced. So you can get some innovative local additions coming into your project that you can then refine yourself into something that's somewhere in between the two that's better. But think about, how can local replacements be done as much as possible. Next. Plug and play design is really key. 20 years ago, when I started in the industry, it didn't exist. People were cutting wires to customized length, doing your own junction boxes. There were training courses left, right, and center on how to build a solar home system. We destroyed that with Barefoot Power. We designed some of the first plug and play kits so that there was always a male and female plug for everything, and that's now standard across the industry. It was basically bringing IKEA type design to the solar home industry. And you've got to make things easy. What you suffer as a result is you don't have customized lengths that fit beautifully. You've got coils of wire left over because you're just giving people 2 meter and 5 meter wires. So if they need 4 meters, they've got a meter left over and they can't cut it. So, but basically it was better to do that and just mass manufacture that sort of stuff in plug and play kits. And it was really appreciated when we did that. And we can do that for higher power systems as well. So these are low power, but the next slide is higher power stuff. So now we've beefed up the plug into an Anderson connector that would be on the back of your car, would be on your trailer. This is like 200 to 2000 watt. And you could build plug and play mini grids out of similar sorts of stuff. You can, of course, make waterproof plugs as well from this sort of material. And again, still extra low the voltage DC here, moving around 24 to 48 volt instead of 12 volt. So that's a very important part, is that part of plug and play design for very easy usability. And preferably it can only go together in one way. Don't have the same plug for your load as you do for your solar panel and get things that could go in the wrong hole. And don't use AC plugs when it's actually a DC device. We see that a lot as well. Next, please. Well, in short, that's it. So I hope I squeezed into the 20 minutes more or less. And yes, I've got some funny stories about refrigerators and melting ice cream. When we gave a product to villages that was split core, so you could actually only use less energy to cool half of the fridge or freezer and still have your ice cream, but the customer didn't understand that. So the first cloudy event, they just had a whole bunch of melted ice cream, and then they listened to what our instructions had been. But it took them making a big costly mistake until they started to use the product. So there's a lot of customer education that goes into this sort of stuff as well, which is expensive and painful and can come across as bad product design when it's actually bad customer usage. So it's a long, hard road. A quick sentence on IoT as well is it often costs maybe $50 to $100 at least to build IoT into a product. That doesn't make any sense if the product only costs $50 to $100. So there's a certain size of product that something has to be, a certain value it has to be, at least several $100 if that's going to work out. Yeah, that's one of the things also to think about as well. And 30% of our customers in Honduras, Vanuatu, they don't even have mobile phone service at all. So if you build IoT into every product you have and investors expect data coming back, there will be no energy access justice or climate justice. The people at the very last mile will be left behind and left out. And so that's something to also think about as well. Okay, I'm done.
Cool. Thank you so much for that, Stewart. That was great, taking us through the your journey to getting here. That was very, very, very great. We are running almost out of time, but I believe we're still gonna have a short amount of time for our Q&A session. So please, if you do have any questions to Michael and Stewart, make sure to use the chat or the hand raise function on Zoom. So yeah, feel free to pop a question in. Doesn't seem like there's much going on in the chat or neither the hand raise function. Well, anyway, while we wait for that, I'd like to inform you about our short feedback survey that we would love you to fill out. We would really appreciate that. You can use the following QR code to access that, and the link will be in the chat as well. Also, we have our newsletter sign up. So if you want to stay posted and see what's going on, feel free to use this QR code. Yeah, to make sure that you don't miss anything in the future. And yeah, just to get back to the Q&A, if you really want to ask questions, it's time for you to do that now. And if not, I believe we're gonna end the session. So yeah, I really urge you to come up with a question if you do have any.
They're typical university students,
Yeah.
eh? Never ask a question. Come on, somebody out there might have one.
Okay, it doesn't seem like anyone is gonna ask any questions. So with that being said, okay, we got a question in the chat. So it says, it's from Talent, and she says, during this completion, are we limited to storage systems?
I think she means his competition.
Yeah, competition.
Yeah, so,
I do believe maybe Sean can answer that.
Hi, Talent. No, you're not limited to just designing storage systems. In fact, energy generation is outside of the scope of the challenge. Storage is not, but it's the appliance and supportive technologies that you're asked to design. So that can be any sort of appliance. We have quite a few examples in the challenge brief if you want to check that out, and that will break it down by theme as well. And there's some great examples in there. We also have examples of previous submissions to get you thinking of some ideas, and that can be found on the website. I can link that to you.
Thank you, Sean, for that. Yeah. Okay, we got another one. It says, is it better to go for pay-as-you-go features when it comes to our end products, or a time payment method in off-grid locations? Oh, okay. One-time payment methods. I don't know if any of you have an answer to that.
I can go ahead and maybe Stewart, if you have any additions, you can just mention. But I don't think it's a requirement, or it's proven to be one of the best. I think pay-as-you-go really works, especially if affordability is an issue. And obviously, you need enablers for pay-as-you-go. Pay-as-you-go requires at least the users to have mobile phones, they have good connections. If you're planning to integrate a curtailment method or a curtailment system for the product, but really it depends on if your customers can afford the product, or rather if the end users can afford the product, through a one-time payment, then there is no need for pay-as-you-go method.
Thank you for that, Michael. I don't know if Stewart, if you have anything to follow up on that one, or.
Yeah, there's a couple of types of pay-as-you-go. One actually has IoT data coming back through the system. You're talking about real voltage and current measurements in real-time environments kind of thing, coming through the GSM phone network. But then there's other types of pay-as-you-go where you just kind of punch a code into a product, and it turns on for 30 days and then turns off if there's no other code. And that doesn't need GSM phone networks, but still you have that ability to turn off the service in the event of non-payment. Those other ones I mentioned could also have a remote disconnect that allows for disconnection of the service at any time. Connected Energy and Okra Solar are two companies that make quite cost-effective, kind of around $50 to $120 systems for that. So sometimes you don't have to invent anything; you can find stuff that's off the shelf there. And the boards for the kind of pin code style things, that's not quite as easily available straight off, but you can sometimes get some supply of that. But yeah, a little bit more difficult, but definitely cheaper, around $5 or $10 per product for those sorts of things. As noted, if somebody's paying for cash, there's no need for it. But inevitably, if you're looking at something that's fairly productive, then it's difficult for people to pay for it, and it's going to need some financing over 1 or 2 or 5 or 10 years. Then it's wise to build that sort of stuff into it, but preferably with off-the-shelf technology. You shouldn't have to design that from scratch.
All right, thank you for that, Stewart. I do believe we are running out of time. So once again, thank you so much to our two speakers for joining us today. It's been really, really great and informative. Yeah, and with that being said, I already told you about the newsletter and the short feedback survey. So yeah, thank you so much for joining us today. It was a great session, and hopefully we'll see you next week for another great webinar. Thank you so much.
Thank you.
Thanks, everyone. Bye.
Bye.